Yeah.
All right. And
Okay.
if I full screen this, can you still see it in full screen?
Yes, beautiful.
Looks great.
Okay,
Yes.
cool.
Yeah. So you want to do a welcome for the recording, Gabby?
Yes, sure. So thank you, Peter, for joining us at the Cloud Native meetup. And this is a really interesting conversation and pretty new from my perspective, because I didn't know either about this possibility, and a lot of customers are using Amazon, and this is really cool topic. So thank you for sharing this knowledge.
Cool, awesome. Thank you, Gabby. Yeah, I'm happy to be here, happy to be sharing. And yeah, so the topic today is securing CloudFormation stacks with Open Policy Agent. And if you've used Open Policy Agent with CloudFormation in the past, you may have been doing configuration validation, and this is going to be a different approach. With this approach, we're going to be using CloudFormation hooks in order to enforce policy on a per resource basis, instead of validating the entire CloudFormation configuration all at once. So my name is Peter. I'm a community advocate for the Open Policy Agent project. I work for a company called Styra. And yeah, a little about me. I'm a professional community builder. That's what I do. I'm a digital nomad. I've been traveling around the planet for the last 4 years or so, and big open source contributor and believer in all things open source. You can find me pretty much anywhere online with @Peter O'Neill Jr. Connect with me on Twitter, GitHub, LinkedIn, you name it. Cool. And this is our agenda for today. We're going to talk really quickly about what CloudFormation is and what it does for AWS. We're going to talk a bit about Open Policy Agent, why it was invented, how it got started, what is it used for, how does it work. Oh, I think someone might have come off mute by accident. Okay.
As we are recording, if you don't mind, go on mute if you are not asking question or like participating. So it's gonna make it that easier.
Yeah.
For
Gabby, maybe
Peter.
you can also. I can't mute them, but I think maybe you might be able to.
Yes.
Yeah.
Awesome. Yeah, and then if you do have questions, do feel free to unmute or drop them in the chat, and I will answer them. But yeah, we'll talk a bit about Open Policy Agent and all of those things, and then we're going to talk about a new feature of CloudFormation called the CloudFormation hook, which acts basically as a function that you can do custom logic in order to secure your stacks, and we'll cover that. And then we'll talk about putting it all together and connecting Open Policy Agent with CloudFormation so that you're able to use Open Policy Agent as part of that CloudFormation hook. And then we're going to go over some examples with S3 and EC2. And if we have time at the end, I'll kind of open it up and see if people want to kind of ask if I can build something on the fly, and then we'll see how well that goes. All right, and so CloudFormation. What is CloudFormation? CloudFormation is AWS's tool to do infrastructure as code. So this is, if you're familiar with Terraform or any other infrastructure as code tools, it's basically the same thing. You define the resources you want, in this case in YAML, and then you submit that to AWS, and it will create that stack, as CloudFormation likes to call it, that stack of resources, right? And so this is going to tie into all the other resource types that Amazon has, right? So this is going to be for creating EC2 instances, API gateways, AWS code pipeline, S3 buckets, basically you name it. I'm pretty sure it works with almost every AWS resource out there. I think there might be a couple exceptions, but for the most part, you can control just about anything you want to build in AWS with CloudFormation, right? And so yeah, as I said, you create that stack, basically define it as YAML, push it to the cloud, and then AWS provisions those resources, and then we'll actually hop into the CloudFormation console a bit later. And then Open Policy Agent. So with Open Policy Agent, OPA is a general purpose policy engine, and these policies you can think of as actions that can or cannot happen, right? And so this is can Alice withdraw money from an account in this application, right? This is can a machine complete some sort of action with another machine or a service, right? So you can think of all of these controls that this policy is going to make as authorization, right? And so being able to define these authorized actions with a policy is the goal of OPA, right? It's being able to have this unified policy language that allows you to define what can happen when users are interacting with your application, or when your application is interacting with itself from microservice to microservice, or from one cloud to another, right? Being able to state what the policy is for each of those components, right? And so when you're looking at authorization happens at basically every part of your application, right? This is going to be from the platform that it's running on, the cloud services. If you're running with Kubernetes, this is going to be deploying containers, right? Those, just the definition of a container and what can be created needs an authorization decision, right? If you're putting data in and out of a database, that's also going to be a policy to define that, right? And then any sort of actions within your app itself, right? You might have RBAC controls, IAM controls, those sorts of things. And then on the left-hand side here, also for your CI/CD pipeline, right? Getting your application out into the world, getting it deployed onto the cloud, getting updates rolled out, getting fixes and change logs and all those things, part of your CI/CD pipeline, right? So being able to secure each of these components is what OPA is designed to do, right? It's designed to be this general purpose policy engine, so that anytime data is moving from one place to another inside of your application, you're able to drop OPA there as a decision engine to say if something should happen or if it shouldn't, right? And this is going to give you fine-grained control over how your application behaves, how your infrastructure behaves, and basically just how your organization is going to handle this. And so let's talk a bit about how this works, right? So as a general purpose policy engine, this needs to be ultra flexible, regardless of the tools that you're using, right? So if you're using tools, if you're using like Kong or Envoy for service mesh, if you're using Kubernetes or Docker for your infrastructure, basically you can hook these up to OPA by having them output output the question that they want to have answered, right? So this might be, can I create this container? Can I destroy this container? Can I let someone access this Linux host, right? And so all those things, right? You basically want to package up that decision as a JSON object. You'll take the information from that service, and then you'll send it to OPA. OPA will then use that information along with any policy that it has defined, and any external or any extra data that it might have to compare it to, right? So we have these three components here, where we have the policy itself, which is going to be defined in a language called Rego, which is a purpose-built policy language that comes tightly coupled with OPA. And so this policy language allows us to define what needs to happen, as changes are happening, and then we will also have the software, of course, right? Being able to say, like which software is the one that's going to need these decisions to be made, and then data, right? So this data is how it's going to differ from the policy itself, because you may want to use data from, let's say, your LDAP server or something else that defines what users you have and what their current authorization statuses are. You may want to say, like, you may want to compare external data, just like date time or any other sort of organization data that you want to pull in. You may want to pull in like pager duty information to see who's on call. So then with this information, you can see like which specific engineer might have access to the resources that you're talking about, right? So these three components kind of play together at the same time, right? And so this is that same kind of diagram on the right-hand side here, showing the service at the top asking the query to OPA and then OPA comparing that query to the policy it has and any data that it's given so that it can return a response, right? And so with that, there are a few features that OPA comes with that makes it really powerful, right? And so the first
Peter,
off, yeah.
Sorry, just a question on the last slide that you were showing. So you're saying, yeah, so each policy decision has 3 components: the policy itself, the software that it depends on, and data that it depends on to enforce that policy. Is that the? And
Yeah.
And it's like like it could be policy and software, it could be policy and data, or it could be policy, software, and data.
No, you kind of need well, I guess the external data is kind of optional, but you're always going to need a policy, and you're always going to need the software to ask the question, and then the data is kind of optional. But yeah, but
Okay.
1 and 2 are always required. Mhm.
Gotcha. Cool. Thanks.
Cool. Thanks for the question. And then yeah, and so OPA has a few features that make it super powerful. The first one is the declarative policy language that I mentioned earlier, called Rego. And so Rego is a purpose-built policy language, meaning that it was designed from the ground up to handle these policy decisions, be able to define things that you might need that are very common to when writing policies, but maybe not common when you're writing normal code, right? So that's why this language is a bit more adept at handling policies, because you have a bunch of built-ins, like working with JWT tokens, datetime, and a CIDR, and a whole bunch of things that come up, like crypto hashes, and working with LDAP data, and working with GraphQL queries, and things that you may want to define in your policy that allow it to work very optimally. And then there's also the being able to deploy OPA in a variety of ways, being able to deploy it either running it directly as a daemon. You can run this as a sidecar in Kubernetes. You can run it as a library. We have a Go and a Wasm library that are very, very quick if you need those ultra fast response times. And then we have with OPA, if you want to do everything open source, there are the management APIs for OPA, which allow you to do all the controlling features you want to build, essentially like the control plane on top of it, where if you want to update your OPAs remotely, if you want to send policy bundle updates, if you want to download the logs or be able to figure out exactly what's going on, right, being able to tap into what's going on just from an HTTP request is pretty powerful, right? And then being able to and then having a lot of the tooling built around OPA that lets you compile these policies. Like one of my favorite is the Rego Playground, play.openpolicyagent.org, kind of just a little testing suite that we put together where you're able to drop your policies directly in there, drop in some data, and see how OPA would respond to that data. And so it is a pretty powerful tool, and very popular one is the VS Code extension, which has a lot of those same components, but directly in VS Code. And then some super common OPA use cases. I think I've touched on all of these, but just a little bit more of a diagram here: Kubernetes, Terraform, Envoy, or custom building an OPA service yourself. And then with that, right, OPA, the Open Policy Agent project, has been around for a while. Created back in 2016, donated to the CNCF in 2018. Graduated 2021, and so pretty strong community. You can find myself and other OPA users in the Slack channel on GitHub. We are pretty active there. So yeah, and with that, I'm going to move into the CFN hooks, unless anyone on the call has any questions about OPA or anything else I've talked about up to this point.
How new are these CFN hooks?
So yeah, actually just gonna
Okay,
show that in
the
the next
segue.
one here.
Okay.
Yeah, good segue though. Yeah, and so this actually just came out in February of this year, and it was a pretty interesting. When we saw this announcement, we at the OPA team, we were actually thinking about when AWS was going to give functionality that was kind of similar to like Kubernetes admission control, because like that's how we tied it into Kubernetes, and it became very popular, being able to just do that webhook style of request that allows you to decide what is going to happen or what. And then so when they announced this in February, we're like, oh, this is like great opportunity. And so me and my team kind of dove in headfirst to build out the integration that I'm going to show in a bit. And so right, essentially how it works is when you are creating a CloudFormation stack, there are triggers, create, update, and delete. And so with these triggers, you're able to define a function, right? And so inside of that function, you'll specify handler logic that says X, Y, and Z should happen when this is triggered. On the creation of an S3 bucket, it's going to say validate that these resource properties are there, or it's going to say, right, when creating a new RDS database, make sure that X, Y, and Z happen beforehand, or when you're deleting one, make sure that an alert goes out to this specific team, right? So being able to configure those, configure those hooks at those specific points. And then these hooks also happen on a per resource basis. So it's not when the stack is created, it'll actually send out those requests as each resource is being validated. And then right now, I think that they have the ability to write these handlers as either Python or Java. So the hook that I'm going to be using is written in Python, and we'll dive into the code just a little bit here. And so with that, right, with the CloudFormation hook, we're now able to, since we're able to define custom handler logic, we use that logic in order to make a call out to OPA. And so here we can see just a quick diagram of how this works. On the left-hand side, you might be doing the same, defining your resources as YAML, pushing that to AWS to create a stack. And then as CloudFormation is actually starting to create those resources, it will reach out and spin up a Lambda function. And that Lambda function will reach out to OPA and basically provide the resource configuration to OPA, and then OPA will compare that to any policies that it's been loaded with. And so there is, it does actually take a bit of work to set all these things up. I think because it is still relatively new. I think that this will improve over time, but in order to set up that Lambda function, you have to use the CloudFormation CLI tool. And the first time you run it, it takes at least like 10, 12, 15 minutes sometimes. Basically, it has to compile a bunch of these different components and put them all together. But then once you have it up and operational, then the only thing that you're really working with, or the only thing you're waiting on, is just network latency. But the initial like creation of the handler does take a while. And so if you do run through these tutorials here, I have linked in these slides, and I can share these slides afterwards. But yeah, so being able to set up the hook and the handler, being able to install, connect that to OPA, and then setting up an OPA server inside of AWS in order to connect the two. Cool. And I'll pause here again and see if anyone has any questions. Otherwise, I'll start diving into the demo and start looking at the code base and how this all works. Cool. Let's dive in then. So here I have the actual hook that we created. This was created by my team, myself, and another advocate on my team. He worked on a lot of the handler function logic, and I helped build a lot of the kind of just the environment and the examples and stuff like that. And so we put all this stuff together to kind of get it pushed out to the community. And so you can use the instructions here to get it set up. And let's poke into the actual logic here. So under hooks, under start OPA hook, which is going to be the name of the hook itself, right? And then we have the Python code here. And so pretty simple here. We actually, when you look at a lot of the other examples that AWS provides, they're much longer than this, but essentially we've stripped out all of the logic and just put in a call to open policy agent, which is why this is a very condensed hook.
Sorry,
so,
and you said, sorry,
go for it, yeah.
You said that this can be Python or
Java.
Java.
Yeah, I've talked to some of a couple of people at AWS, and they said that they're working on a Go integration to be able to define this in Go, but I haven't seen it yet, so I don't think it's out, and I don't actually know when it's supposed to be. But they did say they're working on Go, which is, if that comes out, I'd probably rewrite this in Go. Cool, thanks for the question. And so yeah, so there's just a couple functions inside of here. This first one is get secret. If you want to define a security token so that just a little bit more secure whenever you're running OPA, to be able to pass that token through extra layer of security. And then the second function here is going to be the OPA query itself. So this is what we're sending to open policy agent. And probably the most important bit here is this OPA input. This is how we're actually creating the JSON object that we're sending to OPA. We showed it here, right? Just being able to say, like, passing in JSON. JSON is what open policy agent is going to expect. So this is how we're actually constructing this object, and we're saying action, right? This is going to be that create, update, delete. The hook, which is basically going to be the same hook every time. Or no, this is the hook type. So I think this is I think the hook is the same hook every time. It's the one that we're creating that reaches out to OPA, and then the resource here is the actual resource the individual resource that's being created inside of the stack, right? So we have the ID, which is going to be inside of CloudFormation, just like the name that you give this resource. And then the name, the target type, like EC2 instance, and then the properties is where things get interesting, where this is where we're going to see each of the different components, like public or private S3 buckets, or defining security groups and more specific properties of each resource. And then here's just defining what happens with that response for timeouts and connection errors, fail. And then if we actually get a 200 response here, we're showing what we're looking for is an allow, right? And so if OPA is returning this allow statement, we're going to pass back a success. And if we're not allowed, send back failed. Anything else for the violation, any violations that we're returning, this is going to be the error messages. We're going to pass this back as well. And so that's pretty much it for logic here. And like I said, you can just dive into this is an open source repository, so you can just dive in and set this up and use it. So what I've actually done, because of the setup time for a lot of the stuff, I basically pre-configured everything. But I'm going to talk through like the install instructions. And so you can do this all open source. I just did this in the CyberDAS control plane, just because it's a little bit easier to visualize, just kind of what's happening. But all of the functionality that I'm doing is open source, so you can set this up. You don't need to use CyberDAS. You can set this up on the command line and basically build the same demo. We have it. Oh yeah, here. We have the demo here, right? So basically, I'm not doing this exact demo, but the setup and configuration of the hook is all here if you want to set this up on your own. And right, so looking at the install instructions here, basically this was the setup that I previously mentioned, where you're setting up the OPA server inside of AWS and unlocking the security group to allow OPA to talk to the Lambda function, and creating the CloudFormation hook here. And so, right, these are just various components. Each of these takes like the initial creation. A lot of the stuff takes a while, and then just this this last command here is kind of the main one that matters. So let's pop this open and take a look, right? And so this is actually us enabling the hook itself. This is saying that once we know, or once we have the hook created and uploaded to AWS, then we're saying that we want this thing to look at, to target all stacks. We want it to set to a failure mode, and the property that we're passing is the URL of the OPA server that we created. So we can pop into CloudFormation here, and we can see activated extensions. We can see the hook that I set up earlier today. And so with this, what we're actually doing, because there's no wildcards inside of, or because the hooks don't accept wildcards, we actually have to pass in every single resource type into this hook to say, validate all of these resources or validate any resource against OPA. And so inside of the hook here, I think it's one of the GitHub actions that basically checks for all the resource types, downloads it, and adds it to this list. And then so you're able to see that it's a very long list. I think it says the actual number here. Yeah. So right now it's targeting 692 different types of resources. So if you're adding any of these to your CloudFormation stack, it'll just work automatically, and then send that request through OPA to see if there is a policy that it needs to work with. And so that is the hook itself. Yeah. Then with that, let's actually start looking at the policy. So this first policy that we're going to be looking at is pretty simple. Just being able to say, right, we're trying to enforce a policy that says if public access is not blocked, then we're going to return an error, right? And so we're able to see here, public access not blocked, and then so we have one helper function here, which is just looking for the resource property private. And so actually, just share terminal. So let me change my share real quick. Sorry, I've lost these Zoom controls.
I think if you hit escape, maybe.
I know. So it's not working exactly.
Or turn on your top menu bar.
I think my screen is like mirrored to something else there. Is okay.
They're always in the way when you don't want them to be.
Yeah,
And then
yeah. Okay, let me pull up my terminal. Then let's share my whole screen here. That might be easier. All right, that looks good. Then let's grab this. And so ls, yeah, we're in the right directory. And so I have this very simple resource here. We're just going to create an S3 bucket, super short CloudFormation YAML file. We're saying create this S3 bucket, give it this name, and access control is public read. I think there's the spaces. There we go. Okay. Cool. And so let's actually just create that. That's our confirmation. Now we pop back over to CloudFormation, check our stacks, see that this is being created, and see events. We can see that the hook failed, which is what we're expecting here because, right, that is set to public read, and our policy is looking for private. So we can pop into the decision log here. And if you weren't using this control plane, basically you would just grep the logs inside of OPA for this information, but it kind of gives it a nice view here. So we can see denied and oh, sorry, that's the wrong. This is the most recent one. Yeah, and so we can see here public access not blocked. And so we go back, delete this stack, modify, and recreate here. So now we're this set to private, got our confirmation. And wait for that hook to initiate. Right here, we're seeing that the hook actually completed this time. And so in like a couple more seconds, that will finish creating. S3 buckets always like either 2 seconds or 2 minutes to create. And so there we go. Right, so now the decisions take probably about 30 seconds to get back just because they get stored directly on the OPA server and then have to make their way back through a polling cycle and then make their way over here. Right, and then we should see that allow in here. Yeah, most recent one. So we can delete this and then maybe do something a little more interesting, right? Where maybe it's not just access control private that we want, but what we want instead is to, right, look for very specific configuration properties where we want to say for the resource properties in public access block configuration, we're looking for block public ACLs, block public policy. Oh, actually, let me publish this real quick because this does take some time. Ignore public ACLs and restrict public buckets. And so with this Rego rule, right? So this is, oh yeah, so this is the Rego language that we're looking at here. And so with the Rego language, we have packages defined at the top, import future keywords, which is things like we've added new words to the language fairly regularly. When we think something will make it more expressive, we add things like, we've added a few things like every, in, contains, if. And so, yeah, so here we can see every property in this list of properties, we're looking for it to be defined as true. And yeah, and so kind of funny, I have a string here, a string that says true and not just a true Boolean, because this is just some funky thing of how the CloudFormation hook works, that they don't actually return a Boolean, they return a literal string. And so just a quirk to note if you do define anything that requires a Boolean. And so because we changed that rule and we hit publish, we do need to wait a second in order for it to be deployed, but we can see that it has been deployed. 1 of 6 is up to date. I deleted the other 5 due to setup problems. But you can see that I worked really hard to set up a bunch of OPAs for this, and this latest one now has the bundle or the policy bundle that I just created, and it's been uploaded. So now we can so now we can define this next S3 bucket. Right, and so with this next S3 bucket, we would need all 4 of these to be true, but we can find one that's false if we want and send this over. So what is that? S3 bucket public access. Right, and okay, so let's just actually just create a true one as well at the same time, so we don't have to wait. Give that a different name. Give the stack a different name. Public blocked. Right, create these 2 things simultaneously, save a little time here. See this first one failing, and the second one probably just about done here. We can see that the hook is already finished though, just waiting for the actual resource creation. So when they're denied, get the denial pretty quick, and when they are created, it takes a little bit more time. And then same thing, we can replay that decision to see what happened and then modify based on the response. So we can actually just kind of check out what happened here, see the error message and say, oh, okay, public access blocked. This is what we're looking for. And then define it in here, right? Highlights where the rule came from. And then we can make changes either to the rule or to the configuration itself, right? So we can hit the preview and actually see what came in here. And so this was the resource creation object, and we can see that this one piece wasn't set to true. And so we can validate it right as it currently is. Wait, no. Oh, preview. True. But yeah, we can modify the input here to be what we expect it to be, to revalidate what's going on, and then check that against the rule that we have defined, which would give us the outcome of the created resource that we see here. Yeah, and so next I'm going to cover another common one, EC2 instances. Let's look at this. Yeah, so this is just the entire list of things that you can configure on an EC2 instance. For this demo, right? Like I have created rules specifically for these. So let's take a look at the rules that I've created. So under EC2 instances, oh, let's close the replay here. Oh, actually, I should pause for a second. I've been talking for a while. See if anyone has any questions. Yes, anyone, any questions on the chat or from anyone on the call? I can dive deeper into anything for S3 or cover anything, something else specifically, or diving into EC2 instances.
So you mentioning that it can take a little bit of time for the round trip when it asks for the permission and have the response back, correct?
The round trip to ask OPA for the decision is fairly quick. The round trips for everything else kind of takes a while. The hook itself is fast to get a decision, but then after that, getting the decision logs or getting the kind of information, things populating into CloudWatch or things populating into the decision log in OPA, right? Those things all kind of, they aren't as fast, right? Those things kind of get like secondary priority, so that they get batched and take a little more time. But the hook itself is very quick, so that should not impede the creation speed when you're creating stuff at CloudFormation.
I used Terraform. Now it's a few years ago, and sometimes there were like dependencies on different operations, and so I was wondering if that can be of some concern, but it looks like it's pretty fast in saying yes or no. It's the rest that eventually will collecting all of the proper information on the decision is what takes time, is my understanding.
And I think we can actually see the decision time here, right? So we can see the metrics. Oh, I forgot how to convert these though. So yeah, so nanoseconds converted into actual seconds. Yeah, see if we can do a nanosecond converter 2 seconds, right? And to see like how long did this actually take. Right, yeah. So it's super fast.
Yes.
Yeah, so then you're just worried about network latency. But yeah, so having it deployed in AWS is going to give you pretty good latency on this. Cool. Thank you for that question. Yeah, and then let's cover some EC2 rules here, right? And so I've just defined 3 pretty basic rules that pretty common, right? You might want to say enforce a very specific AMI version. In this case, I'm looking for this Ubuntu AMI, and then so if the input resource property image ID does not equal this AMI, it's going to fail. So this rule will become true, and it will return a false and a fail string, right? And then so the same type of logic, looking for the resource type of T3 small, and the last one here, looking for this specific tag, right? So I have these all defined with this resource here, and oh yeah, so yeah, we have image ID, size, right? So this is not the size we're looking for, and then tags, so that we can create this, and this something else. Oh, let's screw that up. Don't know what I did. Oops. That was a bad copy and paste. All right. Okay. Created that, and let's create, like before, let's create a good one. And you have to always change these stack names. Stack names are also unique, so you cannot create 2 stacks with the same name. Yeah. And so yeah, it's the same as the. You're able to see same thing. Hook failed, and this one hook is already completed. Just waiting for the resource to be created. And so while this is creating, does anyone on the call want to throw out an example that they want to try? We can just build an example on the fly, and you can kind of see how we write the Rego code based around the YAML for CloudFormation. So yeah, if anyone can think of like a resource and a resource property that they want to look for, and then we can write a rule around it. Any takers?
How about an IAM policy where you look for specific IAM actions?
Okay, so you want to create a IAM role with specific permissions?
I want to ensure that my IAM role doesn't have a specific permission.
Okay, cool. Let's check that out. So let's go. Let's look for CloudFormation IAM role. Let's find a template. Right. Once we have the template, we can then define. Sweet, pretty simple here. IAM role. Then let's make a new file here. We're also going to need this top bit. Tab over IAM test. Actually, no, it doesn't like that. It likes test rule. Okay, let's save this. IAM test rule. Okay, so now we have to. I forgot to say YAML. This is syntax highlighting. There we go. And with this. Yeah. Cool. So now we just need to, so we have type defined description. This is an OPA test. So I guess don't need. Yes, we just need to define a policy is what we're actually looking for here. Mention boundaries, not use, session duration, care about that. I would say the one nice thing about CloudFormation Stacks is you can just delete a bunch of things and it will kind of figure it out. So we just need that policy. So let's look at policies. So to say, it looks like we'll also have to create a policy. Okay, so it should be pretty easy. Policy document, policy. I have these. Here. Oh, and this is easier. This is an example. You can look off this. This is better. Cool. So now we have an example that we want to create. And so let's say that we want to, yeah, so we can say that we want this role to only work for these, for EC2, right? So now this is what we're specifically going to be looking for. So let's go back and define that. So then add policy here. IAM slash. So I'm looking at this IAM role. And then rules.rego. Oh, and I guess one thing I did haven't mentioned here is so this package name, we're actually doing a dynamic validation where it's looking so it's dissecting the input and then only checking for rules in that package. So because this type says AWS IAM role, it's only looking for the package AWS IAM role, which is just you don't need to do it this way. This is just a one way to divide up how your policies are going to be evaluated. So you don't have to evaluate all of your rules all the time. Okay, so what we're looking for is this one. So I'm just going to copy this over so I don't have to go back and forth. Right, so let's grab another rule starting point. Right, and so here, let's give this a name. Let's give this a name. It says service must be EC2. IAM service must be EC2. So we'll say this service type. Paste this here. Right, so input resource properties. So it's nested quite a bit. Right, double check that's under properties. And this one statement. Ooh, and because this is a list, we're going to need to cycle through this list. So let's go some statements and these statements. And that will cycle through these lists. So inside of there, we want to do statement dot, all right, statement, yeah, statement dot principal dot service, and then we have another list here, so we have to do this one more time. Some service in service, and then we want to go service is equal to service type. That precision is false. Right, and say service is not allowed that. Okay, cool. We have that. We can publish this. Our decision is unsafe. Oh, I have a typo. Okay. And so the word unsafe here, when we're talking about we're talking in Rego, basically unsafe means that a variable may not be used, or a variable wasn't used. And so it's saying that it's unsafe because the language is declarative. So it expects anything that you provide in the language to be used, right? So because I had a typo here, the word service, or the misspelled word service, wasn't correctly allocated anything. So when it's looking at it from a declarative standpoint, it's saying that this thing doesn't exist, so I don't know what to do with it. It doesn't really like the concept of undefined. And publish changes. I'm just publishing directly into OPA. We would recommend setting up like a GitHub repository for your policies and to push it to Git and then use a standard like GitOps workflow. But for this example, this is going to be fine. Right, so now we have here, it's waiting to sync. If we were doing this with just the open source binary, essentially this would be the same thing. You'd write that policy, you would create a tar file, so you would just zip it up, and then you would just send it directly to OPA via like a curl request. And then this just takes a little bit. It's waiting for OPA to essentially check in. Once it checks in and notices that it does not have the current policy, we'll send it over. And when OPA doesn't have the latest policy, basically it will default to using the policy that it does have until it gets a updated policy. So while that is running, let's take a look at this policy one more time to see what we're doing here. All right, cool. That's done. And this looks good. Actually, and I needed those other. So now let's create another one here. Create CloudFormation Stacks, CFN, IAM, good. And we're going to call this IAM test dashboard. Let's do this. Let's create a good one. Missing something. Required capabilities IAM. Okay, so I've done this before. Just have to add that. All right, I'm just going to Google this actually. Just want to see an example of this. Or maybe I can just go back to the docs. Interesting, it doesn't define it, but it's saying it's required.
There is a hint in the chat.
Okay, cool. Let's check the chat. Ah, okay, perfect. Thank you, Victor. See, now it's collaborative. We're all working together. So this here.
And you want to add a
line break.
Yes, a line break over there. Yeah.
And tie break.
Good spot. See, collaborative. All right, and then so we have that one created, and that should be our good one. And now let's create a bad one. Let's say service S3. Yeah, everything else looks like it's super generic. That should work fine. Right, just to validate that this is working. That. Guess I didn't change it. Good. That's the name twice. There we go. Okay, cool. And so those two things are creating. We should see one still the good one has completed. And we can check the logs in a second. Oh man, the bad one did not get blocked. So let's look at the decision and see why not. Delete this so that I can try again. And so now we can actually just replay this, see where this screwed up at. This one. Let's allow S3. This one. And I have rules. I see what I did. I didn't do a negative. It should have been this is not equal service type. Yeah. So let's publish that. Okay. I'll send that over. Yeah. Still didn't like it. Let's see here. Needs a second. Populate. Check it. Review. Oh, I don't think I waited long enough. Probably didn't deploy. That was probably my impatience. But I think about it. Give us a second to delete. Different stack name. Just to move forward. Always fun building stuff live. Let's see here.
This is a perfect demo effect, don't worry.
Yeah. We got a few more minutes.
Yeah, I think often, one learns more from having to troubleshoot, and when everything's perfect, I think a lot of things kind of escape you.
Yeah.
Or at least me.
Watching the back and forth definitely helps me
Mhm.
learn too. You're like, oh, well, okay, so this is where you would go to check that thing and that thing.
Yeah.
Repo this, right? Jump into the rule. The rule is correct. And it's not equal service type. Service types here.
Can you summarize so far, like how many things did you create? The rule, the role.
Right, so we created this rule. We defined it in this package. AWS IAM role. And so,
And then within this rule, all it's saying is that for each one of these resources, check the service, and as long as it's not EC2, then
it should be good.
it's okay. It's okay. Okay. And so, okay, so that's the rule, and that's being called from that policy
Mhm.
based on the package name. That
Yeah.
is the association.
Mm,
And did you create any, what else did you create anything else besides those two?
Nope. And then we're just pushing it. So the only thing, oh, here, I see it now. No, that's not it. I was gonna say, like, it might be in here. It might just be in this dot notation. The drill down might not be as precise. See, so properties is what everything comes in at. Policy dot statement. And then because it says a list, we're cycling through the list as statements. And inside of that statement, we're looking for dot principal, which is here. And then dot service has a lowercase s. There we go.
Hmm.
It is case sensitive. So
Wow.
And so this is really interesting, the debugging aspect. So it's you don't have any way to kind of log, like you want to log the value that was collected, if it was empty or.
well, we're logging. This is the input, right? So this is the thing that we're validating. So this whole object comes in, but then I guess what we could have done, there is a let's see here. Why it's not showing. You want to see this coverage button should show green and red, basically with where it fails on which line, but right now it's not working. So can't, that I don't know how to debug, but I do think that now that we've fixed that one thing, we'll try this one more time. Do you think that we have it? So let's check it out. Okay. Yeah, there we go.
Hmm.
All right, good debugging team.
Yeah,
right.
so it's a little just sort of, well, you know, when the IDE doesn't give you that, or, you know, sort of
Yeah, not
auto checking of structures, I guess.
mhm. Yeah. So yeah, so that was good. And yeah, and thanks for the example. I think that was a good, took us just enough time. It was just difficult enough for the time that we had.
I think it was quite bold of you to take any example. So thanks that was fun.
Yes.
And Victor, thanks for the example. Yeah. That is cool.
All right.
Is that all? That's all you have for the presentation?
Yeah, I think that's pretty much it. I think I just have some resources in here. You can check out the community. We're on Slack, Twitter. Our docs are pretty good. GitHub, LinkedIn, the Styra Academy. If you're just getting started, just has a bunch of courses, get you started with OPA and Rego. And then yeah, then I'm on Twitter. So that's pretty much it. So the floor is open to questions.
First, let me say that was really great.
Victor says in
Cool.
chat, that was amazing. Thank you.
Yes.
Well, yeah, thanks for being here, Victor. Appreciate it.
Yeah, that was fun.
Right. Yeah.
I have a question that, and I'm sorry if it is not at the right level, but I'm like, when we talk in the Kubernetes environment about using OPA for doing the same type of work that you're doing right now and enforcing policies, can we use the same engine? Of course, the policies that we are defining are going to be different, but like in an environment where you have multiple type of components, like you want to check CloudFormation, you want to check creations in a Kubernetes cluster, like how does that work, the scale of how is the organization of all of these rules and assigned to the specific
Yeah, so here, let me share my screen at the time. So there's a few different ways to configure this. So with my system here, right, like, and so this is a control plane on top of it. And so what I have defined is for each of those different components, right, like, so these are my definitions, my policy definitions for Terraform. These are my policy definitions for Kubernetes. And so each one of these is going to have a set of policies that will go out to that specific system type. So these, wow, the coverage is working in this one. Anyway, the distraction. Well, so like these policies will get sent to that specific instance or that specific type of resource, right? And so like these OPAs are getting Kubernetes rules, these OPAs are getting Terraform rules. And so when you want to actually like share information between them, what you'll end up wanting to use is like a data source. If you want to say like a data source, like LDAP data or Active Directory or something like that. And so you can pipe that information in and then call that data inside of your rules. And so the data can be easily shared between these policies, but the actual policies themselves don't really translate between system types, but data is easily shareable.
Yeah, and this is great because the idea is, let's say I'm provisioning environments for my users, and for the same user, I want to use like the same really use the username, use some kind of information on the SSO or the IAM rule that I have from Amazon, depending on how I'm going to do this. And I want to check that whatever I'm doing on Kubernetes or whatever I'm creating resources external for, because for example, I need to provision a database that needs to go with an application that is running on Kubernetes. And I want to do this based on the development, the team. So you can actually associate this to different type of operation, one that's happening in Kubernetes and the other one that's happening in CloudFormation, for example.
Yeah, and that definitely is a big part of how like these packages, how they work. Like with AWS, I'm defining by package of like the resource type, but you might have packages for like security.networking or something, right? So you can start to separating your policies out in that format. So you can have packages of specific things that can get called upon by different teams, right? If you have a compliance team, right, your compliance team might have a compliance pack of policies that will get referenced by your security team, right? The security team will say, oh, we're just here to enforce stuff that the compliance team has created. And so they know that they have to call like compliance dot minimum dot package or package dot compliance dot minimum or something like that, right? And so that's how you can kind of work with multiple teams to divide up these policies and then reference them in another package.
Okay, thank you.
Anybody else? Any other questions or comments or anything to share? Excitement about trying this? Cool. So are you going on the road a lot, Peter, to share this message, or are you mostly remote?
So yeah, I've submitted this talk to a couple different places. This meetup is the first time I've actually given it. And
yay.
so yeah, so hopefully conference season is still rolling on. Hopefully I get one or two conferences to talk about this. But yeah, this is the first time I've given it. So it's a good warm up.
Good.
Good. And we are going to share the recording, and that is fine with you to publish in our YouTube channel.
Yep, definitely.
So that was a pleasure.
Cool. All right, well, thanks for having me on. Great to meet you, Gabri and Cora. Yeah, I will see you all around.
Yeah, Peter, thank you. Thank you for your time and thank you for sharing your expertise and your knowledge and your enthusiasm and for that amazing live, bold, unpredictable demo.
Yes.
I'm amazed.
All right, have a good day, everyone. Bye.
Well, thanks everybody.
Thank you. Thank you everyone that joined today. Bye-bye.
Thank you.
Thank you.
Marcelo, thank you, Victor.
Thank you, guys. Bye.
Bye-bye.
Bye.